Thanks. Let's be real quick. Dear Father, we thank you for today. Again, Lord, thank you for the students. We just pray you to help us to just use this time we have today wisely to prepare for the test tomorrow. Just pray that you reward the students for all the diligence they have had, putting hard work to do their homework, and that their effort will be rewarded, Lord, tomorrow. Lord, in your name I pray. Amen. So, let's see here. Oh, please turn in your homework 3, obviously. Yep. You open the door. All right. All right, so, no, it's probably on the wrong source. There we go. Again, just to reiterate, so some comments about the test. One, I give the ESN and ETN estimates. If we ask about them. So your main trouble is what? It's finding the M and interpreting the formula, not remembering it, okay? So point 2, theorem 7.9.2, you're not expected to memorize. But I might ask a derivation, but I wouldn't ask a memorization, okay? So in other words, I might say, this is an identity, why is it true? That could happen. I might not, but I'm saying it could. Anyway, so I have everybody's on. Yes, sir. And like I said, last class, it came up that, in the back, you guys. Okay. Last class, the later class asked a number of questions that kind of shook loose some ideas for me about the test. One of those was, yeah, I wasn't really going to ask about the center of mass setup, so I wouldn't be like, here's a mass density, you know, and find the center of mass. I mean, that's physics. Leave that there. So the applications that I would probably that I might test you directly on would just be like areas and volumes. Okay, those are the, I think there should be not a lot of extra effort to pick up on those. So anyway, any questions about this homework or previous homeworks or just? Oh, the other thing I would say is I should remember this is I do not allow you to have a graphing calculator, and you cannot use your phone on the test tomorrow. Like I said this before in syllabus, but just to reiterate, the kind of calculators that you're allowed is the kind I use in here from time to time. I mean, it doesn't have to be exactly this one, right? But this is an example of the kind that you're allowed, something like this. So if it's thicker and you can graph things, no. That's the rule in here. And any questions about that or anything else? Yeah.
Maybe like a problem finding it.
Yes, I actually have that on the handout. I was going to give to you.
Sorry.
No, that's not. Wait, you shouldn't be sorry. Yeah, we can go over it. Absolutely. So here's one I had. Maybe I should do. I have another one. I have another one here. Maybe I should try to get a different one. So you have another example. I picked a lemon for your actual homework. I'm sorry about that. It's just the homework one is rather complicated. Really not a good example. Well, I mean, there's two things in the homework. The one is that just calculate Simpson's rule or trapezoid rule. Pretty much there, I just wanted you to use technology to do it. I wouldn't ask those on the test because well, they eat up a lot of time and they're really not that interesting. And pretty much all I can test there is your ability to remember a formula and do arithmetic. So I'm not that interested. Like I said, I want to use technology to do those anyway. So something like number 15, no. Let's say number 19. Did I do 19 on here? Maybe. Maybe I did 19. Let me look at number 20. Number 20 is pretty good. Section 8.7. Here's a decent example. In the handout, I'm hoping to give to you, if the printer is not jammed when I go back over there, I've got a solution to homework problem number 13 in pretty decent detail. So we're supposed to figure out what n you need to use to approximate this to within an error of 0.01. And that's for A for Tn and B for Simpson's rule of order n. It's so hot here. My goodness, you guys feel hot. I don't know how to change it. This room is too smart for me. I used to have rooms with thermostats where you could like go with stuff. All right, let's see here. So, what we want to do then, right? The thing we have to work with is we're going to set the error in t order n, which is what it's. Well, it's less than or equal to, let's say, b minus a cubed over, what was it? I don't have these things memorized. I don't expect you to either. 12n squared. So this is what I give you, this formula. But you have to know what it means, right? Okay. So like this would be given to you on the test, this thing right here. But you have to know what it means and how to use it. Okay. So we need to do what? Where what? So the absolute value of prime of x has to be less than or equal to m for a less than x less than equal to b, right? That's the theorem. Now here, if you look at it, what do we have? We have a equals to what? 1. B equals to e, right? So f of x is ln of x. F prime of x, this is so much nicer than one of your normal problems. Am I right? Okay. I'm just going ahead and doing all the derivatives out before so I can do parts A and B at the same time. Well, almost at the same time. Of course, I only need up to there for the part A. Okay. Okay, so what do we have? We have the absolute value of f prime of x is equal to what? One over x squared, right? So if you're taking values of x, since we're looking at what? So this is less than or equal to what? No. I mean, maybe. But 1. Right. So the reason you did it is it's 1 over 1 squared, right? Which was 1. I mean, I'm just, that's the man behind the curtain there, right? So that's, we can use that for the trapezoidal estimate. Right? Because if 1 is less than x is less than e, then 1 over x squared is greater than 1. Personally, the way I would think about that as a student, I mean, there's a lot of different ways to think about it, but one way you can think about it, in this particular case, the graph of 1 over x squared looks like the volcano, right? So if you think about values between, say, 1 and e, you're looking at this part of the volcano function, right? And clearly the left end points to the largest value for the reciprocal of x squared. Am I right? So there's your n. Now what? Now we use the theorem. right? Which again, you don't have to memorize. I think I've said that enough now. What we got? What's B? So we got E, yeah, E minus 1 cubed divided by 12n squared. I don't know n, I'm trying to figure that out. And m was 1. And then I set that equal to whatever error I'm looking to obtain, 0.01. And I solve for n. So in this case, n is equal to the square root of e minus 1 cubed divided by 12 times 0.01. Now, of course, I have to use some common sense after this. This isn't really the honest to goodness n, right? This is the, it might give us a, usually almost always will give us a decimal, not a manager rather. So let's see what we get. Cube that. So this gives me 6.5. So that says to me n equals to 7 will do nicely here. Yes, sir.
Doesn't it have to be like an even number though?
The Simpsons rule?
Oh, that's what the Simpsons always.
No, not the way, see, in other books, yes. And that's what confused me. But this book, what it's done is it's reformulated Simpsons rule so that it makes sense for any n. Because its Simpsons rule has built into it actually an even number of subdivisions, but it's all behind the, sort of behind the curtain of the formulas. So like this book talks about S3. And Dr. Subord is complaining about this because he's used to the other thing. And in the other thing, the estimate is different. Instead of having 2,880,
That's what I thought it was different.
you have 2,000, let's see, the usual estimate has 2,880 divided by 16. It usually has 180 in the denominator of other books you might look at.
Yeah.
And the reason for that is that they're, how to say this, I think Rn would be their 2n. And that may not be the right way to say it, but basically if you take 2,880, you divide by 16, you get 180. It doesn't really matter to us, we're only using our book, so we don't have to understand the relation to other books. But if you were doing that, you have to. I kind of like what it does because, I mean, it's nice to be able to use Simpsons rule for any n and not have to worry about it being even or not. All right, anyway, this is pretty, so the fourth derivative is bounded by what? 6, right? Because if you divide by anything larger than 1, you get something less than 6. So 6 is an upper bound. Certainly everything that the fourth derivative of x hits is less than 6 in the interval of consideration, right? And then, so then you look at e minus 1 to the 5th power divided by 2,880 and to the 4th. And then m, which is 6 in this case, you set that equal to 0.01, and that will give you n is equal to the 4th root of e minus 1 to the 5th, times 6 divided by 2,880 times 0.01 to the 1/4 power, whatever that is. Oh man, I had to keep my S1 back. Lazy enough. Before I take the 4th root, I have 3.12. 0.25 powers. I get 1.33 roughly speaking, so n equals to 2 should do. said too much about this now. I'm going to stop talking about it. So the absolute value of this is 6 over x to the 4th, right? But for here, the largest, 1 over x to the b is 1, and likewise 1 over x to the 6th. Other questions?
I don't know how you put that in calculator.
Want to put what?
It's so simple, but I don't understand how to put it in my calculator.
1/4 power? What's that?
Both of them, I don't know what you and stuff like that.
Oh, well, I mean, you can get a very good estimate by just saying, E is what? 2.71, right? So 1 minus E is what? E minus 1 is what? 1.71. I mean, if you use that as an approximation, that will certainly suffice. The problem is this. I feel like, of course, if you just leave like exponential of 1, you should get the value of E also. Okay, guys, so do you have other questions about homework 3, homework 2, homework 1?
I have a question about like the test in general. Is there going to be like designated sections like where like you have to do hyperbolic trig substitutions?
That could happen. There will be other sections probably where I just don't even tell you do this or that or the other thing, just throw it open, you can do whatever you want. You have to do something, but yes, I do expect you to know the hyperbolic trig substitutions. I won't force you to do them all the time, right? But I might ask one off where you're supposed to do it. I might force the issue by asking a question where if you don't do it, it comes at any price. What's a good example of that comes to mind that would work in class? Remember, something as simple as the integral of the square root of a sum of squares, right? If you use trig substitution, you get secant cubed. If you use hyperbolic substitution, you get cosh squared, right? Which do we like? Cosh squared or secant cubed? Cosh squared. Let's see here. If you think back to where we started this course, you might expect that I might ask you something like, show the derivative, something like this, right? Prove the derivative with respect to x, the derivative tangent of x is what? Right? Or show that the derivative with respect to x of inverse hyperbolic tangent of x. Is that below or above? I don't know. No sense of what that was short here. Now I can't remember. Is it 1 over 1 minus x squared, or is it x squared minus 1? I can't remember.
1 minus x.
All right. But you should be able to derive these things. How would you do it? Remember what we did? We did it for 5 different examples, something like that, right? Something like y equals inverse tangent of x, so tangent of y is equal to x. Squared is dead. And then we do what? We got secant squared y dy dx is equal to 1. So dy dx is 1 over secant squared y, right? But hey, that's 1 over 1 plus tangent squared y, which is 1 over 1 plus x squared, right? And there you go. So these aren't really that hard if you know what you're doing. It's about 6 of those sorts of problems that are possible, right? What else do I want to ask you about? All right, here, how about this? I'm going to leave these up here. I'm gonna let you get them, all right? So you guys can come up and get your homework up here, if you don't mind. And then I'll be right back. I gotta make a copy of the handout that I sent for you guys. So I'll be right back.
Dr.
The
Cook,
copier's not jammed anymore.
Dr. Cook, do you want me to keep the video recording?
What's it?
Do you want me to keep this recording?
I think it's fine to leave it recording if you guys don't mind. Here,
Okay.
in case there's concerns about the anonymity of
point
the
it.
class. Here we
Well, I was
go.
going to point at the screen.
I'll point at the screen. That seems like fun. Yeah, otherwise, I have to post 2 YouTube videos. My laziness, you know.
I don't like to just have one.
This is the one you do.
Yeah.
So far, we're averaging like 85.
I could do it too. No, I got one. No, it's like to operate the camera. You're just walking on this desk.
All right, I'm back. Sorry for the delay. Everybody get their homework. Everybody who's here. Well, the same people have not picked up their homework for both stacks. It's a good sign. Right? Let's go. I think he's in the later section. Oh, nice. Okay, so the sheet I'm going to hand out to you guys, it's what it is on the back side, there are the answers to the problems from 8.7 that were ugly. And so I won't try to scare you by giving you complete solutions of those. And what I did instead was just to go ahead and solve one which I thought was more representative of what might be a test question, which is a lot like the one we just did here, right? Number 13. So there's another example for you. And I think I did the e to the x problem another day in class. That's another good example of one that wouldn't be too bad for time right now. So my point is, anyway, that's all I have to say about that. I guess I your homework in the front. So guys, any questions about homework 3 or homework 1, homework 2? Missing one?
I took anyone.
What's that?
Anyone as well.
Oh, you need a whole. Sorry. Great. I have everybody's homework 3, by the way. Well, look at the solution. So just look at your handwriting, just not you. Oh. So I would expect, some sort of basic inverse trig function knowledge, like maybe I give you graphs or ask you to raise a graph of like inverse sine or something like that. Should spend some class time trying to, or I don't know, it might just be simple as here's a question I could ask. Sine inverse of x is equal to x, let's say y. And sine inverse of sine of y, or x rather, is equal to x, or y an element of what? Or x an element of what? Give me an interval of real numbers, which I can fill in the blanks there. You guys know me? So what's the answer to the top blank? Remember the domain of inverse sine is the range of sine. So yeah, -1 to 1. And this is true for what? This is true for, I think what you're just telling me. Right, so actually inverse sine is a local inverse. It's actually the inverse for sine restricted to that particular interval of real numbers. And there are obviously similar questions I could ask about what? Inverse cosine, inverse tangent. So you go back and you look at the first couple days of class. What did we cover in there? What kind of knowledge are you supposed to have? How can I test on that? Think about that a little bit. But then, of course, the majority of the test is integration, right? So what have we learned in here? We've learned integration by parts. Integrals of hyperbolic functions, right? Integrals of various powers and fractions of trig functions, right? like you guys said, partial fractions. What's the other big one I haven't mentioned yet? This is a big one. Integration by parts, right? Trig substitution. Hyperbolic substitution. In short, your homework, right?
What section was integration with hyperbolic? I thought we just said that about
Well, 7.8 or 7.9. Secondary.
I think we just did the
Okay, but, implicit within the problem of doing hyperbolic substitution is being able to integrate things like cos squared, or centrifuge, stuff like that. Some of this, of course, is like 7.9, not that hyperbolic substitution course, but the hyperbolic sine and cosine 7.8, right? If I asked you to prove the identity cos squared minus sin squared equal to 1, how would you do it? Oh, split it out. So here, EPXs. Yeah, so like cos squared x minus sin squared x as well. You take that, you square it, right, and you subtract. And I think I may have done it a different way when I did it in class before, but this is probably the way I would do it as a student. I didn't have a better idea. I mean, this is like the not too tricky way of doing it. So that's going to be what, 1/4 e to the 2x plus 2 plus e to the minus 2x. When you FOIL it out, the minus 1/4 e to the 2x minus 2 minus e to the minus 2x, right? Plus e to the 2x, right? And then, of course, things cancel, right? And you're just left with what? 1/2 plus 1/2. Which is 1, and there you have it. So, you should not be scared. It's probably ask you to verify trig and verify hyperbolic identity. You just go back to the definition of Cauchy cinch and work it out, right? Yes, sir.
Will we be able to use imaginary exponentials?
Yeah, I think so. I think you should be able to do that. We spent a lot of time on it. So a typical question involving imaginary exponentials might be something like derive, let's see here, cosine theta times sine theta equals to whatever it's equal to. All right. Using imaginary exponentials. Or, I don't know, I guess I could just say use whatever method you want. But I'd like you to be able to use imaginary exponentials because I think it's not hard that way. So cosine theta, sine theta is what? It's 1/2 e to the I theta plus e to the minus I theta 1/2i e to the I beta plus e to the minus I beta. Right. And so that's 1/4i what? Theta plus beta plus e to the I. Ooh, I have a, what's wrong here? This right here is supposed to be minus, right? In sign. So, plus, so this is actually minus e to the I theta minus beta. And then plus e to the I minus I theta minus beta. This term is coming from this times that. And I factored out minus theta. I mean, minus the minus is a plus beta. And then I have minus e to the minus I times theta plus beta. And then you regroup terms, right? Oops, I should put a minus out here, right? Right. And so what you have, once you sort it out here, we've got 1/2. There's not everywhere, right? So 1/2 the sine of theta plus theta minus 1/2 the sine of what? Theta minus beta. So I probably would actually put over here in the statement of the problem the answer that you're supposed to work out. You know. So the question might be something like that: derive this using imaginary exponentials or some other suitable technique. Do you guys know another suitable technique? I mean, I haven't showed you another suitable technique. I think one technique is enough for this. So what do you really need to know about imaginary exponentials in order to make use of them? Really, maybe three things, right? The one is that e to the I theta is cosine theta plus I sine theta. The other thing you really need to know, it's kind of your lifeline for working with them, is that cosine is 1/2 e to the I theta plus e to the minus I theta. And the other thing is that sine of theta is 1/2i e to the I theta minus e to the minus I theta. If you know these three things, and you know how to do algebra, and you have confidence in your ability to do algebra, you can go a long ways with those. You can derive most of the trig, and you need just one of those three things. I will shut up about that. Questions about integration? Any questions about homework 3, as I've been asking? Any particular problem you guys have trouble with? Not in 8.7. So 8.6 number 1 was an awful lot like the one I did in class, right? Did you guys get that one? Let's see here. Let me find my laser. Yeah, I have a laser. I have a laser. Oh, that's not useful. Look at these ones. Sorry. Was it this one? The e to the x one? Yes. Yeah. Okay, let's look at this one here. All right, so to remove the square root, we just let u equal the whole thing. Well, that's kind of uninspired, but it works because then, of course, it makes the radical just u, right? Oh, now I see a green circle. I gotta find an attenuator for this thing. I never charged the batteries. They came like this. Square it, you get u squared equals 1 plus e to the x. And then you can solve for 2u to u is e to the x dx, right? But you notice that we have only a dx here, right? So I need to solve for dx, basically. Dx is what? Dx is, you see what dx is? It's 2 du divided by e to the x. See what that is? That's just the dx, right? Now, I can't leave e to the x. That's in the world of x. We need to convert it to a u thing. So that's easy from here, right? U to the x is u squared minus 1. See that? At which point I've got a rational function, right? So I can do partial fractions. But my first move has to be to convert it to what? I need to convert it to a proper rational function plus a polynomial. So if you can either add 0 like I did here, right, to make this 2 appear, or you can do long division, whatever floats your boat. But you should get 2 plus 1 over 2 minus u squared minus 1, right? And then what? Yeah, that's the inverse hyperbolic tangent of u. And so there you have it. Of course, you can also write it in terms of the theorem 7.9.2 as this. Again, this is that thing I don't expect you to memorize. If I want you to use it, I'll provide it for you on the test. Okay. if I wanted to ask a challenging question on the test, I might ask you to derive part of that theorem. There will be some question which is challenging, right? And then there'll be other questions which are more like homework.
How many questions are there typically?
There are typically enough questions on your test here. It's, I don't know, I mean, it doesn't mean anything for me to tell you 5, 10, 15, 25, I don't know. Not 25. Not 5, but somewhere between 5 and 25. There's usually, we'll find, there you go, 25. I don't know, we can go back and look at previous years and see what happened. Let's do a, we can do a, what's it called? Actuarial study of it. Let's see here. Nine to 4. Oh no. What does that mean? That means playtime is over? No. Well, we only have this to look at. Here's my 2011 test.
Don't you have all your tests on the website somewhere?
I think so. Let's see here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, of course, this one's out, right? We don't even know what that means in proper. 11, 12. What? Wait a minute, I was counting 12. 10? How'd that happen? Oh, I must have put 10 out of order. Oh, look, in the Bayes cross substitution. Those are bonus questions at this point now. It'll be shorter than this, almost certainly. There's a simple reason for this. I have 70 students this semester. Do I want to grade a lengthy test for 70 students?